find the 100th derivative of y equals cosine of 2x. Now, if we're asked to find the 100th derivative, there better be a pattern, because if there's not, we would actually have to differentiate 100 times, and we would be here for a very long time. So the goal for a problem like this is to take the first few derivatives, maybe 4 or 5 or 6, and see if we might be able to find a pattern. So let's look at the first derivative. If we take the derivative of cosine of u, we know the derivative of cosine is negative sine. So this is going to be negative sine of 2x times the derivative of the inside is 2. So that's going to be negative 2 sine of 2x. All right, let's look at the second derivative. We've got the negative 2 out front, so I'm just going to keep that negative 2 out front and then take the derivative of sine of 2x. The derivative of sine of u is cosine of u, so that's cosine of 2x, times the derivative of the inside. Again, the derivative of 2x is 2. And now we've got negative 2 times 2, which is going to be negative 4 cosine of 2x. Good. All right, let's take another derivative. The third derivative here, we're going to keep that negative 4 out front, and then we're going to differentiate cosine of 2x. The derivative of cosine of u is negative sine of u, so negative sine of 2x, times the derivative of 2x again, gives us another 2. We keep on popping out an extra factor of 2 in each of these, so that's going to be part of the pattern. And if we look here, the two negatives cancel. 4 times 2 is 8. We've got 8 sine of 2x. Let's do another one. Let's look at the fourth derivative. You might already be seeing what's going on, but the more we have, the easier the patterns are to see. So let's do one more. The 8 goes out front, and then we've got to differentiate sine of 2x. The derivative of sine of u is cosine of u, so it's going to be cosine of 2x, times the derivative of the inside gives us another 2, so that's going to be 16 cosine of 2x. Now you can see there are some positives and negatives in front of these, but we also notice that we've got patterns. We've got powers of 2. We've got 2 to the first, 2 to the second, 2 to the third, and 2 to the fourth. It looks like we're going to have 2 to the nth power if n is the derivative that we're taking. And then it's either going to be sine or cosine, and it's either going to be positive or negative. But I want to point something out. If we ignore the 2 to the n, if we ignore the coefficient, when we did 4 derivatives, we cycled from cosine to negative sine, negative cosine, positive sine, and positive cosine. We've cycled all the way back to positive cosine. And so if we were to go 4 more derivatives, we would end up with negative sine, negative cosine, positive sine, positive cosine, and then another 4 would take us back to positive cosine. So every multiple of 4, we end up with a positive cosine. And notice that we're looking to get the 100th derivative. That is a multiple of 4. And so we are going to end up with a cosine of 2x. And then out front, the coefficient is going to be 2 to the nth power, where n is the derivative. That's just 100 here. And so we can say that the 100th derivative here is going to be 2 to the 100th power times cosine of 2x. And there we go.